Hey everybody, welcome. Today I'm going to go through Table 5C of the Canadian Electrical Code Part 1, and what you'll note first of all is I don't have Table 5C here, I have Table 2. This is where everything starts from. Okay, this is the basis for Table 5C. So what Table 2 is, it's the allowable ampacity for not more than 3, count them, 1, 2, 3, copper conductors, okay? And what we have on Table 2, we have the size, the AWG, 14, 12, 10, so on and so forth. We have the insulation rating of the particular conductor, 60, 75, or 90. And what we're going to do is we're going to get a situation where we have more than 3. So what do? Well, that's where we bring in our table. This is where Table 5C comes into play, okay? So, ampacity corrections for factors for Tables 2 and 4. We just done on Table 2 because it's copper. Table 4 is aluminum. And remember, Table 2 allows up to 3 conductors or 3 copper conductors. And what this table is saying is what if you have more than 3? From 1 to 3, the correction factor is 1 because there is no correction factor. But the idea is if you have more than 3, say from 4 to 6 or from 7 to 24, you have a ton of them, a ton of conductors bunched together, and they have to dissipate the heat into the atmosphere. Well, when you have a ton of them together, it's harder to dissipate that heat. You generate much more heat. So what you have to do, you need a correction factor, or you have to derate the amount of ampacity that can go through the conductors, okay? So here's the numbers, here's the correction factors from 4 to 6, 0.8, 7 to 24, 0.7, so on and so forth. Now, the best way to go through this is to go through a question. So we'll bring in a question here. Find the current carrying capacity of 6 AWG number 12, 75 degrees Celsius conductors all placed in the same conduit. So our starting point here is we go to Table 2. We always start with Table 2. That gives us up to 3. So we'll look for the AWG 1275s in a normal setting, okay, just up to 3 of them. So we come back to our Table 2. We have the AWG 12s, 75, and what we get is in a normal condition, up to 3 of them, those conductors in a raceway or cable, each can handle 25 amps, okay? So we'll bring back our question here. So the idea is each can handle 25 amps, but here's the thing. We got 6 of them. It's generating way more heat, and we got to knock that 25 amps down a bit. So what do? Now we go to Table 5C and find the duration factor, okay? Or as they call it in the table, the correction factor. So what did we say we had? We had 6, so we're in this range, between 4 and 6. The correction factor, or the duration factor as I like to call it, is 0.8. Essentially, whatever we could have originally, we can have 80% of that now. So if we had 25 amps originally from that Table 2, now we can have 85% of that, okay? So you get the 25 amps times the 0.8, and the new amperage rating that it can handle is 20 amps. There you go. That is Table 5C from the Canadian Electrical Code, Part 1. Thanks for watching. Have a great day.